Today I'm going to talk about what we've titled Cloud Shootout. And it actually all stemmed from a real problem. And the reason it's a real problem is because it's very hard to do. So Cloud Shootout and other ways, curiosity killed the cat. How I learned to stop worrying and love the Cloud Shootout. In fact, this is a very stressful thing to do, but we'll get to that a bit later. I don't really have to talk much here, because I got such a wonderful introduction, but I work at Jade Abbott, and my work is largely around natural language processing, using cloud-native software, so we're doing everything up there, and that kind of, I've been working in the cloud for so long. I never had to manually ever configure a server, really. We've been working from get-go, which is nice. I feel sorry for everyone who had to. And yeah, I work for a startup called Collider, and we do a lot of other things. So yeah, so this is what we want. We want to be able to say, use Cloud X because of ABC, right? I mean, the number of times it's a client, it's a boss, it's someone, you're about to start a new product, and they want to know which one we're going to use, who, and why. And you usually get some feelings. Everyone has a feeling about a specific cloud. Usually via their branding, they've got some sort of, feeling towards AWS. They've known it for a long time. Perhaps Google's very shiny. They feel attracted to using Google. They've been using Microsoft throughout, the business's lifetime. So like, let's use Azure. But they're feelings largely. Sometimes you get sales reps that come and create new feelings, but they're feelings. What we actually want is to be able to have real numbers, real experiences about real applications, and real-world use cases. And largely that is up to date, because we can often go online and we can have this Google, and you'll get something that was probably 5 years old. Let's talk about our players. So I'm going to get everyone to make a little bit of noise. I've got background being in a band, so we've got to make some noise for our players. Our players today, I would like to introduce Azure. Where are Azure in the house? Make some noise, shout louder. Azure, yes. Cool. If anyone's interested, a lady called Gina Ray made these comic book illustrations of our clouds. So definitely if you're interested in any comic books, come speak to me. I'll give you the details. So we got some Cloud Azure over here. Next up, we have GCP. Where's our GCP? A round of applause for GCP. And last but not least, AWS. Make some noise. Where's synthesis? You should be making more. You should be dancing. So these are kind of large-scale cloud providers. There are many more, but we're going to talk about these ones because these are the ones you always see. And what we're trying to do is we're trying to compare them and get some metrics that we can understand to aid our choice. This is very difficult. What products? There's a suite of 20,000 different products, and every day there's a new one. What are we comparing? What are we comparing on? What metrics? Is it performance? What does it even mean? Is it cost? What are we determining the cost of? Of course, it's very hard and difficult and time-consuming to do this. You have to run the same thing on 3 clouds, so who in their right mind is going to go do that? And it becomes outdated very quickly, like I said. We live in an agile world, things get released every week. So what was valid now in a month is probably very outdated. They've probably updated their costing, they've probably updated the products they're using. The products may not even exist or exist in a completely different form. And the other thing we need to acknowledge, we are very biased. We are biased by these feelings we have. These feelings about which brand we actually like the most. Like I said, what the internet said, you can Google it. We've probably all done it when you're trying to aid this choice. They're either outdated, they're incomplete. This one over here, that's the first time I'm going to use a little pointy thing. Yeah. This one's actually quite good, but it's generally too general. But it tries to go in depth, and they redo the study every year. The other ones over here, it basically says we're not including Azure because time and cost, so we're not going to do it. And then you can find some actual academic studies where they try to do it. So this one's comparing startup time on a VM, but that's 5 years old, so that means absolutely nothing now. Absolutely nothing. The world's changed 100 times over since 5 years. I can't remember what I was doing yesterday, never mind 5 years ago. So we started small. We're like, well, there's too much to compare. We could make these, and originally, if you looked at the description of the talk when we first incepted it, it was a group of us all wondering. I think all of them are all here. And we all incepted this. Oh, we're going to do this, and we're going to take 3 types of applications, and we're going to compare them, and we're going to run them for 3 months, and we're going to load test them for hours, and it's going to be amazing. And then you end up with more, despite the amount of effort that takes to do, you end up with a couple of other issues. And one of the other issues is that how do you dissect where bottlenecks are? How do you really understand what's going on? If you're running these giant real-world applications, how do you really figure it out? So we had to start small. So what I've decided to do now is, first of all, propose some metrics that we think would be valuable for us. I do think they're quite incomplete. We could be here forever discussing every tiny little thing. But I think they're ones that matter to us a lot. So let's propose some metrics. Let's figure out what are we actually measuring. Then, in the good scientist way, we did a small experiment. And the small experiment I'll introduce you now, it's a very stupid little experiment, but it demonstrates a couple of important things. We go detailed into the results, and more than anything, we've provided a starting point. And it's all on GitHub, and we'd like, if anyone's interested in kind of making this more automatic, ideally you should be able to click a button and kind of run it, and be able to do this in a repetitive way. So we made a little thing. The idea is amidst take high requests. We want it to be able to scale up, so many web requests, and it needs to have a kind of relational database in the background. Let's do that. That's a very basic use case. We've all created the system. A couple of us, it doesn't matter what product it is, you're going to end up with probably some version of that. So once again, in the interest of very good science, we're going to go with the same code. So have the same code for each platform. They all support Kubernetes, so let's go with Kubernetes and Docker, so we can have the same environments. A couple of other things we wanted to keep in mind was we wanted to only use cloud provider documentation. Because it's no good that some wonderful person on the internet is telling me about it when the company itself can't even explain it to me. And that's, we're depending on the community, which is great, but also we should be able to depend on people to be able to support their own product, in my opinion. We wanted to use a managed database, so there's going to be installing of databases. I specifically bring this up because Google doesn't actually support SQL Server, and their recommended way of going about it is to go manually install it on an instance, and that's what you get. Good job, Google. And we want to keep the architecture as similar as possible, so similar infrastructure. And that's quite tricky if we're working in this kind of nodes. We've got these nodes, and have to specify a size for them, and they're not actually comparable. So if you go look across the clouds, they don't have the same instance sizes. They're slightly tweaked. For some competitive reason or some architectural optimization reason, they're slightly different from each other. So you actually can't really get the same box, so we'll get them as close as possible. So our little picture, we've got Kubernetes is some sort of scalable web service. It's going to scale out. We're going to hit it with a lot of requests. It's written in Golang because I like Golang. Not JavaScript. Where are my JavaScript kids? That's very soft with JavaScript. It's usually a lot louder. Did it in Golang. Very efficient language. Love it. And I'm using Postgres because Google didn't support SQL Server, but also I love Postgres. So we've got some managed SQL over there. You can go on GitHub and get the code there. Very, 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 very simple. This is all it does. It's very stupid. I love writing stupid little bits of code. So this one, basically, you hit the URL, and it generates a random string, saves that to a database, just returns the string to you with the ID. Very straightforward. Nothing fancy there. I do think this design, or this particular program, actually hurt us in terms of experimentability. We'll discuss that later. Let's acknowledge our biases. It's really important when we're doing science to acknowledge who funded the research or what your actual biases are. Kubernetes is a Google product. It's probably going to influence something. I didn't use any Microsoft products. That's probably going to hurt Azure and benefit the other two. I personally use AWS every day. And I've written blog posts about how Google tech lies. For many reasons, their marketing team and their tech team are not really the same person. They're definitely not the same person. Disclaimer, not a Kubernetes expert, a Kubanoob. This is mine. When you hear this, remember it was invented here. I'm a Kubanoob, and that's kind of the point. When you're dealing with a new tech and you want to experiment with this stuff, and you want to get something up running and quickly to feel what it's like, it shouldn't be a giant, large mission. So we want stuff that can kind of help us along our journey. Our metrics, really important. We've got ease of use, we've got performance, cost, flexibility. Cost is a really interesting one. I think everyone in this room is just waiting for cost. But ease of use became also quite dramatic and kind of frightening too. And I'll go through how we're going to do those. Because I'm at Retro Rabbit, I'm going to instill the rabbit rating. 5 small green bunnies. is really good. And if you have one bunny, that's really bad. And I think that's true of life. If you have the more bunnies, the better. And ease of use, how are we going to measure ease of use? I don't have 30 people to do the same thing. Oh, I do. I had grads. I probably could have made them do this. I don't think they would have liked me very much. But how are we going to try and measure ease of use? It's a very hard thing to measure. So this was my proposal. I don't know if anyone knows this particular comic. Quality measures, I've been told I can swear, so what the fucks per minute. Code quality. So I figured maybe we can measure cloud quality. Cloud ease of use is also what the fucks per session. It's a good cloud when there are very few what the fucks, and it's a bad cloud when there are many. So this is our weird methodology. We've got our WTFs per session, and I introduced another concept, the wows per session. Every time it just made something really easy that I didn't have to think about. And I looked at all of those things. You can see the full list over here. I'm not going to go through all of them, but you will see some of them. And I classified them into a whole bunch of things. So we've got reliability, we've got some UX issues, documentation. Really, we poo-poo documentation because we don't want to write it. But as a product, you really should be working on that. I am because I am is notoriously a disaster in every single system I think I've ever used. So who has had a problem with identity management in any of the clouds? Hands up. Some people aren't saying it. He's very nervous. I personally, I don't know if I'm a complete idiot, but every time I try to do anything with identity management, I end up giving people admin access just because it's easier, and I can't be bothered, frankly. Which is awful. That's the exact opposite of what we should be doing, right? And then lastly, tooling. So here's my WTFs per session. I've counted them to give you a summary. And this was each of the clouds. So Google got 7, which I guess makes sense. They invented Kubernetes, so cool, it's theirs. Azure. What happened, Azure? I want Rory in this talk. He works for Azure, but he's talking now, so that's not going to work. And I just wanted him to heckle me or something, but he's not here. And then AWS 11, which is, considering you've been doing this for a very long time, 11 WTFs. Don't worry, we're going to go through what they were a bit detail later. In my wows per session, good summary, we've got 9 wows from Google. Surprising. Once again, I wasn't a fan of Google. Azure, 7 wows. Good job, It's high WTFs, but good wows. And AWS, 1. And I think it was a consolation one, if I remember correctly. It was sort of like along the lines of, something wasn't too bad. And I think it was their repository manager. Wasn't too bad, and I kind of gave it as a, well, there you go, have that. Of course, we needed ratios are very cool, so I thought I'd look at the ratios. I said, oh, great. So for every wow, how many WTFs do I have? For Google, we've got 0.7. So that's less than 1 WTF per each time you went wow. Azure, 2. That's not too bad. Particularly when we're comparing it to AWS's 11. What? Go a bit into documentation. Big part of ease of use if you're trying to set something up and maintain it. It needs to be complete. I remember the days of, the MSDN, you'd have parameters and they just didn't explain them. They were just sort of there towards the end of the method, and the entire documentation just left them out for no good reason, really. Accurate, it should be, and I think it's probably the hardest problem we've probably got in computer science, is that our documentation is very rarely accurate because our code moves at a rate of knots and our documentation doesn't. I'm not talking less about code here, I'm talking about product documentation, so slightly different. Useful and accurate tutorials. And I'm not, here we want cloud tutorials. Remember, the cloud providers provide tutorials on how to use their tool. It's all great that the world came up with stuff, but now I've got to go digging through 20 different Medium posts to try to figure out how to do it. That's not what I want. It should be easy to navigate and search. So let's look at the Google documentation wows, because I put this one up because they really are wow, and you don't know until you've actually tried to do anything in Google, and it's horrifyingly beautiful. So first of all, whatever product you have, they will say, here's a product, these are the 20 different ways you can try to connect to it. Here's a tutorial detailing each way how to do it. Not only that, but the links they give you before you begin do this. Each description is exactly what you're doing and why that matters. You don't always have to read it, but very good. The links work, so if you have to activate some sort of identity. You just click on the link, it takes you to the console, you click it, done. Worked. Strange. And even the what's next made sense. So I'm like, oh, I've got a database. I've now, I'm trying to figure out how to connect to it. What do I need? Oh, yeah. Now I need to actually build, this part of the app engine, or I need to build, figure out how to scale it. And they're always really useful. AWS gets you this. You can't really see it, so let me go through it in detail. How to create an EKS cluster, which is, Elastic Kubernetes, Elastic Kubernetes system. First of all, you open CloudFormation. What's CloudFormation? Doesn't tell you. You just have to open it. So let's open CloudFormation. Great. Open CloudFormation. What am I doing? I'm creating a stack. What's a stack? I don't know what a stack is. I do, actually, because I went and looked it up. But why do I have to create a stack? That's 3 lines. You're not telling me there's no link. OK. I'll click the Create a Stack button. Choose a template. Now I have to do something with S3. What is going on? So I kind of did this, and from this, Google was very, very high. Azure, very, very good as well. A couple of inconsistencies. AWS got 2 bunnies. Poor form. You've been around the longest. Reliability. I mean, you click on something and it does the thing. Or you type the command, it does the thing. And I have to say, all of them had slight things that just didn't work here and there, particularly when it came to documentation. They were all doing not great. Let's talk about tooling. And cloud tooling is interesting because you've got, your kind of dashboards. You've got your little CLIs that you'll be using. So this I didn't realize how wow it was, because I thought it was going to be crap. Is Google's got an inbuilt cloud shell, and I was like, that's brilliant. It's probably rubbish. It probably doesn't do anything. I've been down this route before. It's in your browser. It's running a terminal. And it's a fully fledged terminal. You can do anything in it. And what's great is pre-installed with all the versions of everything you needed. Everything's up to date. You don't have to update anything. It's all there, just running. So this is really useful for us. We've got a lot of .NET developers who've never looked at a terminal in their life, to be frank. And they suddenly, I said, oh, no, they're going to have to dual boot, and no, I don't want to install a VM. Or you need to set something up, and you just want to play around. It's there. Great. Very cool. Azure has one. It doesn't support Docker, and I'm dealing with Docker, so that was a bit annoying. So I thought, fine, I'll download the thing. I mean, I don't know what another thing. They charge you to create the shell. They charge you for storage. I was like, isn't this meant to be a tool? Like, this is probably a really tiny thing you're creating here. Also, I can't do anything on it. It's not like I can build Docker images on it. So why are you charging me for my tiny piece of storage, Azure? So then I thought I'll install the CLI, which was stupid. So you have to run the CLI in the correct version in my version of Ubuntu. I had to install the Docker, which meant I couldn't use the Docker in the Docker, because we have Dockerception, and that got out of hand. So I was like, oh, great. I'll have to install the dev release. I had to go to GitHub and manually install it and hope it compiled and ran on my machine and hope things weren't completely in beta. It was a bit silly. AWS doesn't have any attempt at a kind of cloud bash, and that's fine. I thought this was a wow. And if you didn't have it and your native tool worked really well, your normal CLI, I was like, that's fine. But they require you to download a 30 megabyte authenticator just to set kubectl, which is a little Kubernetes tool to interact with all these things. You have to download a 30 megabyte thing to be able to get so kubectl could connect to your cluster. And then, I mean, the documentation is on this, and you can't see it. But over there, it's like, makes me download something that's 30 megabytes, and then wants me to go manually put it into the path. I was like, can't you do this already? I don't understand. Not only that, but you have to now, when you run anything, you have to manually create your subnets, manually create your VPC. You have to manually do everything and make sure you are copying those little IDs down somewhere, because you're going to need to copy-paste them into a command later. And none of the other ones needed to do this. So this took me half an hour, because I can't copy-paste very well. I suppose none of us can, really. If we were, we'd all be amazing developers. We just have a copy of Stack Overflow. I finally got a laugh. I was a bit more worried about Cape Town. They seem to laugh. You guys are very nervous today. I'm not that scary. Plus, I know some of you, you have to laugh. I'm going to be angry at you later. So in terms of tooling, we gave Google a 5 stars, not based on its kubectl integration was very easy, same with Azure, but largely based on the fact that it had these, great, the great Cloud Bash. It had a whole bunch of other things that I haven't gone through. To do with the stack drivers. So stack drivers, they're monitoring everything. You just got like logs out of the box, and it just worked. There was no manual configuration. You just got logs. You get logs out of the box for anything you do on Google, and they're all centralized in a very interesting way. Azure deducted some points because of their very interesting problem with their Docker. And AWS didn't provide me anything, and I fought with it for an hour. So you got a 1 bunny. Permissions and IAM. Why? Why every time? Full access. This is a use case we did. Full access to Athena. We've done this with CloudFormation. We've done this with 100 different things. Why is it always like this? Every single time. And there's this JSON thing. You've all seen the JSON thing if you've worked with AWS. And I'm very stupid, so I definitely don't use the JSON thing, and I don't understand security. So I want something to be able to click on and go, yes, full access to that tool. I think we spent more time fighting with these tools than actually writing any of the code at a stage, which is just terrible. And I'm going to talk about, I could go in more detail, but, Google does this beautiful thing. If you try and do something you're not allowed to, it says, here's a link, click on it. It'll take you to the exact permission you need, and click enable. It's in the error message. Why? Where have you been? Why does no one else do this? In Azure, our company currently can't administrate our company domain. The administrator can't get on. He set as an administrator, and he still can't do it. Have we fixed it? Where's Igu? Have we fixed it yet? No, there we go. We still haven't figured. We kept trying. I think we had a meeting just to sit down and try to sort it out. We couldn't. So they also get a 1, because that's also, identity shouldn't be that hard. Otherwise, we're all just going to give everyone admin access to everything all the time, which is the opposite of what it's trying to do. UX should solve a problem. Should be intuitive. Things should be discoverable, and it should allow users to make mistakes. Google gave 5 because every time there was a way back, everywhere there was a good message, there was always error messages. Azure. Also very good, well done, trying hard. A couple of things I didn't like your IAM. It's really weird. They also use weird words for everything. Don't know why. Azure, yeah, that's the other one, couldn't find ACR. Azure, AWS, there's a reason it's a picture of a Mecca, right? There's a reason it's not beautiful. AWS is low level. It doesn't care. It's not built for people like me who can't administrate systems. It's built for people who actually can administrate systems. They've probably been doing it for a while. I think the AWS administrators have just been building it for themselves for a long time. I said this in Cape Town, and no one threw anything at me. So I'm hoping I can say it here. No one's going to throw anything at me. Flexibility. Flexibility is actually quite, I thought I made a whole topic over it. It's actually quite easy. It's just about your instances. How can I play with them? And this becomes really annoying if you're trying to optimize costs. And all you need is a little bit more CPU. And you can't, because then you have to upgrade the memory. And they've got this suite. If you look at Azure and AWS, you've got a suite of these boxes, these types you can choose. And they very rarely actually perfectly solve what you want. Google has sliders. You can just slide the number of them up. You go, oh, I want more memory, slide it up. Or I would like more CPUs, please. Oh, I'd like to change that later, slide them back down again. What? I suppose it's not surprising. Google, they basically, they are the web at this point. They've been web native for longer than us. They know how to build these interfaces. Azure got 1. Would anyone like to guess why Azure got 1? Azure got 1 because if your boxes are too small, they can't do certain things. You can't put a small box on a VPC. So if I created a small database, I couldn't put it on the same network, and I had to go out the network and come back in order to access my own database. And I just thought this was just terrible. What they're trying to do is obviously force you to upgrade your box. I think they don't like having small boxes because then they can't, probably hurts optimization. It's harder to optimize. You've got lots of tiny little boxes lying all over the place. And like I said, at GCP, completely custom scenes, and AWS has just got the limitation of you've got those pre-configured boxes, right? Performance. What does that mean in cloud? What do we mean when we say performance? Are we talking about the code? Are we talking about the hardware? Are we talking about the network? What are we actually talking about? So spin up speed we thought we'd look at. We try to test some scalability, see how quickly they can scale and how that works. See the error rate, request speed. Need to figure out what that actually means that we're testing. Talk about that later. Limitations of all doing this, because testing performance is very tenuous and very hard to actually do. So this was my methodology. We took Apache JMeter, which is a load testing tool. And because I hate myself, I thought I'll add a fourth cloud. So I'm testing from DigitalOcean for fun. Because why not? I thought it would bias everyone else if I didn't test from DigitalOcean. So I was like, I'll do it over there. I sent 10,000 concurrent requests. Like, remember, these are tiny boxes. I haven't actually shown you the box what the specs are. You can go look on GitHub. They're very similar, but they're tiny little 1 CPU, tiny bit of memory. Send 1,000 requests at them. Didn't put Nginx in front of it because the load balancer. I just wanted them to fail, actually. They needed them to fail so that we could prove the scaling. Then 5 hours of doing this to monitor it, mostly because I was running out of time. I really needed to finish this. And I said, oh, well, we can auto-scale our pods. I'll say we can have 1, we can have 10. Great. And I did this with varying difficulty. And then measured errors, measured latency. So performance was, like I said, interesting. My percentage of errors on Google was 50%. That's very high. Throughput, not great, not too bad, especially when you compare it to these ones. Let's go back again. Look at that throughput. What are you doing? What is happening to you? I mean, what? Azure. That's horrifying. And then I remembered there is a reason we use AWS. 6%. The others were above 50, this is 6%. And what does that mean, really? When we look at what did we just test? So when I thought about it, the only thing I could come up with, we're testing their hardware, so maybe their CPUs are better. We're testing their ability to virtualize, how efficient is their virtualization. We're testing their network configuration. How optimal is that network, right? And we're also testing their load balancers, because why not? So that's actually that's what I figured we tested. And AWS, having been around for so long, or much longer than the others, seems to have honed on this. I always feel like Google just throws money at a problem, so it'll be like, oh, just build another data center, it'll be fine. Azure will be like, no, let's AWS will be like, no, let's work on this. Let's make it optimal. And they've clearly spent a lot of time doing that, because that's incomparable. Instant spin-up speed. What's really funny about this is that the only person who actually, they're people now. I mean, we saw the characters. The only person that told us how long they took to spin up boxes was Azure, and they're the slowest. So it's actually on the dashboard. When you spin up a box, there's a giant sign that says, oh, I took 6 minutes. Oh, thank you very much. And then I actually went to the effort of trying to measure the other two, and Google's less than a minute, and AWS is less than a minute, so sorry, Azure. But I really like the honesty in telling me how slow you are. Scaling was a complete failure. None of them scaled. And I was like, okay, well, clearly I'm not hitting them hard enough. No, I was. If you look at this, so this is Google's. If you look over here, that's above 80%, and I set them to scale when they got above 80% for a small amount of time. No. Instead, I had, I think, 3 replicas set up, before scaling. No, stayed like that. So that wasn't it. And I thought, well, maybe that's the same with the others. It was the same with Azure. AWS, I can't see this number. That's 20% CPU usage. So they didn't scale because they didn't need to. Better hardware, better virtualization. This is my theory. Very interesting. Like I said, limitations. We've kind of tested their load balancers. We've tested their networks. Nothing scaled, which is really irritating. And 2 of them probably maybe for valid. I didn't understand. AWS, I think, does scale. I know because I've tested it once before. So when you do actually hit scale, it actually does scale. And they've got the entire CloudFormation, which is a nightmare to set up, but it does actually help the scaling part. We've got non-production-like instances. These are very small. In future, probably like to do that a lot more. And we need to investigate what the bottlenecks actually are. Cost. We've all been waiting for cost. Let's get some shout-outs. Let's go through my teams again. Who do we think is the cheapest? Someone said Google. So who thinks AWS is the cheapest? Hands up for AWS. Got some AWS. Put it there. Who's got Google? Oh, you've all tried. Who's got Azure? Hey, there's someone standing up for Azure. Yeah, it's interesting. So we thought we'd look at a broad range of things about cost, because it's not just what you pay, it's how easily you can optimize. It's the calculators themselves, how accurate they are. So we looked at the calculators. GCP and Azure are beautiful. You can save them, you can email them to people, you can work on them later. They're very click, they make a lot of guesses for you. You can tweak things if you edit the settings, so they give you nice defaults. AWS gets you this thing. This thing, I don't know, like, what is this thing? You know how long it took me to figure out I had to go to the next tab to actually get the estimate. I'm like, what am I doing? Where's the numbers? What's really stupid about this is that the Kubernetes isn't even in here. So I went through every single one. I'm like, I can't find Kubernetes. EKS just isn't in there. Is this still on me? I have a feeling it's slipping. If it falls off, I apologize. So yeah, didn't even feature. I was like, oh, I'm going to have to manually calculate it, which I had to do. So calculators like AWS, just get a life, fix it. You're a very big software development company, just fix it. Cost monitoring, very important. How can we monitor our costs? Google, very nice. Very detailed. You can set different metrics, you can look at different ranges, it's beautiful. Azure, very good, a little bit more overview, but nice. AWS, you first have to dig into 10 trenches of documentation only to get a link that tells you it's not available for the next 24 hours. It does become available, not in 24 and 48. And then it does give you quite a nice thing. But you did have to dig deep. And I don't like that dishonesty, actually. So I gave them a 3 for AWS, not doing too badly. 4 for Azure, and 5 for Google, who did quite well. Cool, calculator. This is what the calculator said we're going to spend on our instances. So right now we've got Azure at the most. Is anyone, well, this is on the calculator. Anyone surprised? One guy who was supporting Azure, maybe not even him. AWS gave, a little bit less, and Google was the cheapest. Okay, are you ready? I'm going to show you the actual cost. What just happened? And like what I like here, in Cape Town, people did think they thought AWS was going to be the cheapest. Yeah, everyone seems to have really figured that one out, a lot of people, and realized Google's cheaper. AWS, that's horrifying. That is over 1,000 Rand more. And the other two got less. So now we've got Google has the most cheapest cost. Azure, which we were worried about. Azure is not that much more, 500 Rand more. And they have a data center. Probably doesn't support Kubernetes yet, but sure. And then AWS, I'm just frankly shocked. So there's our thing. I penalized the other two slightly for being, too nice in their estimates. And, and AWS got 1. Just don't. Well, cost optimization, all more fun. Like here's Google's. It gives you in the dashboard. This is your instances, your compute engine's dashboard. It gives you a little recommendation. How can you make it smaller? That's amazing. I didn't have to look. It wants me to spend less money. Never has anything wanted me to spend less money. So maybe my boyfriend, my mother, and everyone else I know, but my bosses, they keep, anyway. Azure Advisor is also a nice tool, a little bit deeper in the interface, but when you find it, it doesn't only advise you on your costs, it advises you on your security and a number of other things. And AWS has a blog post, because of course they have a blog post. You have to go read through reams of documentation, how to optimize it. Well done. A blog post. Clearly you don't care about us. So they get 1. Some important costs. Didn't really include these that much, but I thought I should, in the interest of costs and giving a valid view, I want to talk about things you didn't necessarily know. Obviously, and thankfully, because I'd be a bit worried at Azure if it wasn't, having a giant database on Azure wasn't cheapest on Azure. So if you do SQL Server, it's cheapest on Azure. If you're doing something Postgres, it's cheapest on Google. If you're doing GPUs, cheapest on Google, and these are the V100s. So if you're doing any machine learning, these are the ones you want. They're beautiful. Ditch the K80s. These are the cool guys. And then what has become an industry standard, and it's the cheapest, is S3. Ooh. I'll stop throwing things in. Next time I'll throw it to someone. So here we have our competitors. How are we feeling? Azure, Team Azure? Anyone? And Team AWS, still excited about something? Yeah, it's just a little bit quieter. We got performance. That's important. It's really important, right? And arguably, your costs could be cheaper if you can get more performance out of the same box. So still hasn't lost the game there. And then Team Google. Yeah, Team Google, very surprising. So our final scores. Ease of use, 96.6%. Azure, 63. All right, it's a pass. And AWS 33, just sort your rubbish out. Flexibility, I gave Azure the least, and we've got 100% flexibility on Google, because what's better than a slider? Performance, 100% for AWS. I want to emphasize this point. That is like unbelievable, and I'd like to have a really serious discussion with Azure about what is happening. And Google should be better. Costs, at the top we have Google, and not far behind Azure, well done, and AWS got 36%. I gave 5 bonus points to Azure because they have a local data center and they give you the prices in rands. So claps for Azure, thank you. Thank you. Has who's created something on the local data center? Hands up, I haven't yet. How did it go? Shout. Slow. Is it a resounding slow? Well, we've shown that, so I'm not surprised. I minus 5 points for not having SQL Server. And some people laughed at me in Cape Town because they're like, why would you need SQL Server? And I'm like, most corporates use SQL servers, right? It's really important. And supporting it badly is one thing, which is AWS's implementation of Kubernetes, because they've got their own product. This is just not having it at all and saying you're going to manually install it. It's like an active thing against Microsoft, right? So here are our final scores. We have, in this side, Google Cloud, well done. Congrats, shout out to Google. Second, Azure, and third, AWS. Just to expose how I calculated those, not very well. I kind of took averages, I just calculated percentage over the total. In future, I'd like to take each of the attributes, take 25% contribution from each. I will probably update the slides and do that at some stage. And let's talk about some future work, because we're clearly making a lot of interesting things here. So production grade databases I'd like to try with, instead of these stupid little things. I think that hurt Azure quite badly. But yeah, screw them, it should have. Why don't you little databases or anything have access to it? I'd like to run a production level application. So an actual app that's got some caching and, all the good things. I'd like to run tests for longer, and I'd like to use some of the existing benchmarks, particularly when we're looking at networks and things like that. There are existing benchmarking tools. I'm going to see if we can run those. So yes, that is me. Ask me questions. I believe there was a process for doing that.
Thanks, Jade. Can we have a round of applause?
Let's talk.
I'll invite you to ask questions. We've got about 10 minutes. You don't have to log a ticket. You don't have to pay for it. So this is your opportunity. Just that handle again, at DerivcoT. We'll give you a minute or two just to log anything that you want to ask.
DerivcoT.
At DerivcoT.
Team.
T.
T.
The letter T.
The letter T, not like
it was supposed to be the dome, but then Twitter just cut it and I wasn't going to fight.
Okay. I'll stand up here awkwardly.
all that for a very short question. Just in terms of the error rates, how are you measuring them? Is that from the tool doing the
Yeah, so it's
okay.
from the tool, and it basically said what requests failed. Yeah.
It's like a 500 kind of.
Yeah. Whatever it was. Yeah. So like there wasn't enough code in my actual tool for anything to actually go wrong, unfortunately. One there, and there's one here, and there's a couple here.
So from what you learned, would you be using Google Cloud Platform in the future for stuff you're building?
Yeah, I already am. But yeah, I will be using Google Cloud. I would still always look at the others. If you can make this really automatic, then I'd like to test it, or easier, I'd like to test it for different, be able to test based on the use case. And thanks to Richard for looking up a lot of the stats. Did a lot of research. It helped me when I was dying and had 100 things to do.
Hello.
Hello.
So,
Yeah.
does it count as Google's docs if you had to Google where AWS's docs are?
It should, yeah. It's Google's Docs for AWS. There's some really odd things, for instance, this is related to that. You can connect Stackdriver, which is this Google logging tool. You can connect it and monitoring. There's a whole bunch of stuff. You can connect it to AWS, which I thought was kind of cool. So I did that, and it didn't do anything, so well done. But weirder than that, it started logging that AWS project as if it was Google's. So I kept trying to I could create a cluster in AWS. I don't think it actually did that. I think it just created it internally. I thought it was really, yeah, they got a bit of a minus on the thing. It was very strange. It's one of their WTFs. Yeah, random question. Yeah. Any more?
Anyone else?
Any tweets? Who tweeted?
Just have a look at my notebook there.
Oh, notebook. Oh. Cool.
You might just have to hit refresh.
Do I still code? Is that me? Personally? There's a previous session. Oh, yes, of course, that would make sense because you're CTO. And then we've got yeah, that was it. Cool. Well, thank you very much. I would please go rate my talk. Feedback is always invaluable. You can say something mean if you'd really like. Sometimes that's more valuable. Sometimes sometimes I won't care. If you tell me I'm having too much fun on stage, I'm going to ignore you. So this happened once. And definitely enjoy the other speakers. It's a rush to go see all the good talks. They're amazing. The people themselves are amazing, so definitely go speak to them afterwards. And yes, have an amazing day.